Hello, I am a spoiler warning. This following video contains spoilers for Jurassic World and Jurassic World Fallen Kingdom. You have been warned. Let's talk about the Jurassic World representative from my neighborhood, Mosasaurus, or as I like to call her, Aquasolitor, because that means water jumper, and yeah, that's mostly what she does in that movie, jump out of the water. Because our protagonists are above the water, she needs to be above the water to be seen, so she jumps a lot. Question is, could Mosasaurus actually do that? Let's look into that. Before I get to that, with Mosasaurus I have to address the inaccuracies of the movie's version of the animal, because they kind of screwed over his ability to jump with the specific changes they made. So one thing I can't even address in the right way is the size of this animal. The real Mosasaurus was up to 18 meters long. Most didn't reach that size, but the largest ones were that size, and it's still possible that somewhat larger ones did exist. So the 21 meters the Jurassic World Mosasaurus officially has is not that out of range for this animal. Problem is, if you see the movies, it doesn't stay that size. It seems to magically change its size from scene to scene. I mean, you can't tell me that this and this are all the same animal of the same size. It has about the right size when it jumps out to eat the pteranodons and babysitter. It's much larger when it jumps out of the water to eat the shark, and you can even see that the splash is a very large splash down by a really large animal, so that is larger. And then there's the helicopter attack, where that thing is gigantic. That's at least 50 meters. That's a kaiju. It's not a dinosaur anyway. It's a lizard, but you get what I'm saying. So we're working with the real Mosasaurus, up to 18 meters long. I give them the upper size limit, so 18 meters it is. And then we get to other stuff they screwed over with Mosasaurus. One important thing is the skin. If you look at the Jurassic World Mosasaurus, it's really nubby and gnarly and crocodilian in its skin, which is something that's done with Mosasaurus a lot, but they have nothing in common with crocodiles, despite being very large reptiles of the sea. However, crocodiles are actually much closer to dinosaurs than Mosasaurus are. Mosasaurs are lizards. They're related to the monitor lizards, such as the Komodo dragon, and we have skin impressions of these animals, and they look a lot like the skin of, well, the Komodo dragon, with small scales that are rather smooth, very smooth surface. Scaly, yes, but smooth. And that's good if you're an aquatic animal, because you need to be smooth to swim faster. Swimming faster also means you can jump higher, so this is something that really helps it jump more. You see by now how the changes they made for the movie actually lessen Mosasaurus' ability to jump as high as it might have been able to. A really large change they made to the Mosasaurus is in its tail. The movie Mosasaurus has it has kind of a tail fin, not really. And the other mosasaur in the franchise, the Tylosaurus from Jurassic Park the game, has something similar that's a little closer to what it actually looked like. But in actuality, Mosasaurus should have a tail fin much like that of a shark. And again, that's really significant for its ability to swim fast and to jump. Because with this tail, it actually could swim the way a shark or a whale does, not the way a snake or a lizard does, as was believed until recently. The movie does get away with doing the tail wrong, because this was discovered only in 2015, so the same year Jurassic World came into cinemas. But over here we examine from the current knowledge, and looking at that, it did have a tail fin much like a shark, and that also helps it to jump like it did in the movie. So for the creature, that's actually a plus. And what we get for jumping is actually quite beneficial. We get the equivalent of a very large dolphin crossed with a shark, but the size of a humpback whale. And it moves the same way as a humpback whale too, so testing whether Mosasaurus could jump that high is actually really easy. We just need to look at a humpback whale and how far it jumps. Humpback whales are known to breach the surface and jump into the air a lot, and they usually do it to eat plankton. They circle it with air from the air hole and then swim up and breach through that with open mouths and swallow everything that's within that ring they made of bubbles. And when they get to the surface, they breach it and jump. It's a side effect of their feeding behavior. Mosasaurus could conceivably do something similar. Mosasaurus did not eat algae or plankton, so it's not likely a side effect of that with Mosasaurus, but Mosasaurus has been found with pterosaurs, flying reptiles, in its stomach. So it is possible that what we see it doing, chasing after the pteranodons in the one scene, is the real hunting behavior of a Mosasaurus. And taking the humpback whale into account and how far it can jump, and humpback whales can jump about 10 to 12 meters. That gives us a good estimate what Mosasaurus could do. Maybe it could even jump further because it's more streamlined than a humpback whale. But we take that as our guidance and we can see, okay, 10 to 12 meters. Given that Mosasaurus is about 21 meters long in the movie, that's a little more than half its body length. And yeah, that about checks out, with the exception of the helicopter scene. But then again, their Mosasaurus also grew to at least twice its actual size. I mean, look at how tiny the helicopter is and the guy on the ladder, and you can't tell me it's perspective, because the guy on the ladder is actually in Mosasaurus' mouth in the end. There's no perspective going on. They are in the same plane in the picture. So yeah, they screwed up with size there. But other than that, yes, Mosasaurus was probably able to jump that high, and it's even possible that this is something Mosasaurus routinely did to feed. So on the one hand, well done Jurassic World, that works really well. On the other hand, yeah, the changes you did do to this animal actually screwed it over in that regard, but probably not by that much, because humpback whales aren't completely streamlined either, so we'll let that slide. This one actually works. What now follows is the ending for the original Jurassic World. I was prepared to call shenanigans on this, because yes, the jump is possible, we already established that, but the landing seems really dangerous. However, in this scene Mosasaurus lands from a height of about 7 to 8 meters, give or take, using the Indominus as a reference. And that height is in the range that a human can fall down from without major injuries. Of course, that's when that human falls on soft ground like grass or something. And here Mosasaurus falls on concrete. However, Mosasaurus bones are much denser than humans, because as a marine reptile, it has those denser bones to be heavier, to have it easier when diving. So this makes the jump and the landing in this actually possible for Mosasaurus, even though I have no idea how she aimed the jump for the Indominus, because she shouldn't have been able to see the fighting dinosaurs at the shore. But technically it's possible, and the nice thing is, because Mosasaurus has very massive bones, and theropod dinosaurs usually have hollow bones, or at least very light bones for their size. This even makes it realistic for Mosasaurus to drag the Indominus the way she does, because the weight difference is actually pretty large. Science disagrees how large exactly, but Mosasaurus, very massive bones, very heavy for its size. Indominus, probably lighter or even hollow bones, very light for its size. So that makes this part of the movie surprisingly possible. And there you have it, the science of Mosasaurus jumping as compared to animals that exist today, jumping and falling. And we see this is one of the more realistic parts of Jurassic World, even though Mosasaurus itself keeps changing its size throughout the movies. Next up, we'll be taking a look at the home planet of the predators, and after that, at the origin of the Pokémon.